Hello everyone. Good morning, good afternoon, good evening. So today we are going to learn VPC configuration and its best practices. So here we will learn about what are the VPC configuration steps. So in order to configure VPC in the data center, below are the steps described. We will take these steps one by one and will discuss all its best practices associated to it. So the first part is configure a VPC domain. Then we have to configure a VPC peer keep alive link. Third one is to configure a VPC peer link, and finally we have to configure a VPC member port. Now configuring the VPC domain and a peer link. So if we want to configure a VPC domain and a peer keep alive link, so a VPC domain contains maximum 2 nexus switches that are grouped together to participate in a VPC. So we will have a 2 pair of switches that will be a part of a VPC domain, right? A VPC domain is configured by entering a following commands in the Nexus CLI. So if you go to the Nexus CLI, we will have to configure a VPC domain. So this is your configuration, and here you have to provide a ID. It can be anything, numeric value, right? Now, so following are the steps to configure a VPC domain as a part of a VPC best practices. First one is configure a VPC domain ID globally on both peer switches. So on both peer switches, you have to configure this command. Now configure a VPC peer keep alive link on both peer to ensure that this link is operational, else VPC domain will not be formed successfully. So if we want to write a command, how we will do that? We have to write it like this: VPC domain 10, under that peer keep alive destination IP address of second peer switch, source IP address of first switch, VRF. If we want to configure our peer keep alive link under management VRF, we have to provide management. Else, if you want to have a dedicated VRF, then in that case you have to provide your dedicated VRF ID. Right now, when the VPC domain ID is same on both peer switches, what will happen? The VPC system will generate a virtual VPC system MAC address which is same on both peer devices. So if you have a VPC domain ID 10 on both peer links, so what will happen? A VPC system will create a VPC virtual system MAC address, and the format will be like 002304 EEBB, and this is your hexadecimal value of VPC domain ID. So because we have configured a VPC domain 10, so what will be our VPC MAC address, system MAC address? 002324 EEBB, and 10 hexadecimal value of 10 will be it will be 0A. So this MAC address will be present here also and present here also. This is my A switch, this is my B switch. So because my virtual system MAC address are same, it will looks like a single logical switch. Okay. Now, because having a same VPC system MAC addresses on both peer switch, it will makes the access device which is going to attach to VPC with both peer switch. The third access device will see that it is going to connect to a single devices, which means because you have a same MAC address, virtual VPC system MAC address same, right? And you are going to configure a port channel here on a VPC. So what will happen? The two peer link will logically act as a single device because of a same MAC, and to third device it will look like it is connected to single switch. Okay, now we've also options to configure a VPC system MAC address manually. You can configure it via command system MAC inside your VPC domain. Okay, now there is also another MAC address. We say it as a VPC local system MAC address. VPC local system MAC address, and this is your switch burn-in MAC address. Switch burn-in MAC address, and this MAC address is used for all other communication in a layer 2 domain like STP and all other communication. So we have a two MAC address. One is VPC virtual system MAC address, which is used for configuring a VPC, and second is VPC local system MAC address, which is a switch burn-in MAC address, which is used for all other layer 2 communication like STP and other protocols. Okay, now we will see what is a VPC role. So when we configure a VPC, they are identified or they are defined by two VPC roles. One is a primary and another is a secondary. So as per VPC best practices, peer switch which has a lower priority will assume a role primary and another switch will be secondary. And if the priority of both switches are equal, then a VPC system local MAC address. And what is a system local MAC address? Burn-in MAC address will be used into the picture, right? So if you want to, here we say that those which has a lower priority will assume a role of a VPC primary. So we can configure a role priority command under VPC domain. So we can configure VPC domain 10, and under it, we can define role priority, and its value would be 1 2 6 5 5 3 5, right? Now this VPC role defines which one among the two VPC peer switch will be processing the BPDU and respond to the ARP request, right? So ideally what happens, the VPC primary switch is used to process BPDU on behalf of root bridge, and it also respond to ARP request. So ideally what happens, if I have a VPC domain, right? So what I will do, if this is my VPC primary and if this is my VPC secondary, so as a best practice, I will make it as a STP root also, and I will make a for all HSRP and gateway it will be primary. Will be configured into the primary as per a best practice. Now, as soon as we configure a VPC primary and a VPC secondary role, there is also operational role. So if the switch 1 is a VPC primary, it will also assume a role of operational secondary. Operational primary. And this switch will also assume a role of operational secondary. Right now, this operational primary and operational secondary role is driven by real-time behavior of a peer devices. Right, so this role is assumed by switches based on the real-time event. Right, now let's suppose you configured a role priority, right, on a switch 1 which is lower, so it will assume a role of a primary, and second switch will assume a role of secondary. Likewise, it will assume a role of operational primary and operational secondary. Now let's suppose if this primary goes down, so what will happen? This switch, even though the second switch is a secondary switch, but it will assume a role of operational primary. Okay, it will assume a role of operational primary. Now let's suppose after some time, this original switch 1 comes up. So the VPC role is a non-preemptive in nature. So it will not assume its original role to operational primary, rather it will be operational secondary now. Right, so this switch 1 will be my operational secondary, switch 2 will be my operational primary, even though they are primary and secondary as per their configuration, but because of non-preemptive nature, they will assume a role based on real-time behavior. Now, if you want to, preempt this behavior, if you want that your primary should be operational primary and your secondary should be operational secondary as per, best practices. So what you will do, you have to configure a role priority with a lower value than the other peer devices. Second thing, after doing the configuration, you have to bounce the peer link, I mean shut or no shut, to force the changes. So if you do these two steps, your primary will be operational primary and your secondary will be operational secondary. Now, how to configure a VPC keep alive link? So this link is configured to send a periodic keep alive message to both peer devices per second. So every second it sends a keep alive packet that I am alive, I am alive, I am alive, and its timer is 1 second. So this link is used at boot up of a VPC system and make sure that both peer devices are up at before forming the VPC domain. Now there are 3 types of timer associated to it. So one is peer keep alive, right? Second is keep alive hold timeout, which is of 3 seconds. After 3 seconds, there will be a peer keep alive timeout, which is of 5 seconds. So for 1 second is the timer of peer keep alive link. Peer keep alive hold timeout is of 3 seconds, and peer keep alive timeout is of 5 seconds. Okay. Now, what is this all about? What is peer keep alive hold timeout? So if I talk peer keep alive hold timeout, what is this? Right. So as soon as my peer link goes down, as soon as peer link goes down, this timer gets activated. This timer gets activated, right? And during this time period, and during this time period, I mean of between 3 seconds, the secondary switch will ignore any of the keep alive message. Secondary switch will ignore any keep alive message. In the sense, because your peer link is working, because your peer keep alive link is working, so for every second this keep alive packet will be sent, right? But as soon as your peer link goes down, this timer gets activated and the secondary switch will ignore all the keep alive packet which it is receiving from S1 by that time period. I mean by till 3 seconds, and it will not perform any action against it. Now what is the peer keep alive timeout? So during this period, secondary device will look for any keep alive message from a VPC primary device. If a single hello message is received, the secondary device concludes that my peer link goes down, but I have a peer link, I have a peer device which is sending a keep alive messages to me, and it concludes that there must be a dual active scenario, and because of its detection, it will disable the VPC member port. Okay, so if I write it during this period, okay, if secondary device receives any keep alive packet, right, it believes that there must be dual active or split brain scenarios, and to protect VPC system from this behavior, it will disable VPC member port of secondary device. So it will disable this part. So all our traffic will be going from here. Okay. So now we will see, what is the behavior if VPC peer keep alive using management 0 with a dual supervisor on in each Nexus 7000. So in that case, there is a strong recommendation as per VPC best practices that whenever you are using a dual supervisor in a Nexus 7000 and using management port for a keep alive, never do point-to-point connectivity like this. Like management 0 of a soup 1 should not be connected to management 0 of soup 1 of Nexus secondary. Second, the management 0 of soup 1 standby of Nexus 7K to management 0 of soup 1 standby of the Nexus 7K secondary. So this is your Nexus box. This is my primary switch. This is my active supervisor. This is my secondary supervisor, standby supervisor. This is my secondary switch under which I have my active supervisor. I have my standby supervisor. So I should not connect it like this. Not recommended. Why? Because let's suppose your active supervisor goes down and this supervisor becomes active. And if your peer link is traveling via here, it will never reach here. So in that case, your peer link will be down. It will show down. Okay. So in that case, what we should do, we have to connect our management port over some different layer 3 switch, which can do routing, so that management port of switch 1 should able to reach to the management IP of switch 2, right? So here we can connect it, even though if any of my switch management port goes down or my link goes down, still I have a connectivity and I can reach. So my peer keep alive link will be alive. Okay. Now the third option is the VPC peer link configuration and the guidelines. So VPC peer link is a 802.1q trunk port channel interface, which is used for carry a VPC and a non-VPC VLAN. They are used to carry control plane traffic. They are used to carry CFS protocol traffic, right? Because they carry the CFS protocol traffic, they are tagged with COS4 value, right? It is used to carry the flooded traffic from a VPC peer device, any broadcast or any unknown unicast traffic. The peer link is used to carry the HTTP BPDUs, HSRP hello packet, IGMP updates, all the other above. Okay. Now there are some supported and unsupported topology for peer link. So make sure that the port you are using to connect peer link on both switch, the module number, model number will be same. So if you are using M1 here, use M1 here. If you are using M1 here, use M1 here. If you are using F1 here, F1 here, use F1, F1, F2, 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 right? So this topology is supported. Okay. But if you are using M1 here, F1 here, not supported. F1 here, M1 here, not supported. F2 here, F1 here, not supported. So the both side will have should have a same module. So now we will talk about the object tracking. So in some Nexus 7000 series, let's suppose you have a M1 module, single M1 module, and let's suppose if you have a F1 module here, M1 module here, F1 module here. M1 module is used for your peer link. So let me write here. M1 module is being used for peer link and your uplink connectivity. And F1 module is used for your access switches. Right. So this is your scenario. Now what happens if your M1 module goes down? M1 module goes down. So in that case, your peer link and your uplink connectivity goes down. But your F1 port is up. Now, if you're let's suppose you have a server here, and if sending a traffic, the traffic can be sent via this port. Once it reaches to the S1, because M1 module is down, its uplink is also down and its peer link is also down. So you will have a traffic drop. So in that case, and in order to protect this scenario, what we can do? We can do a object tracking. Also, because in that, if my M1 port goes down, my peer link goes down and my uplink connectivity have also gone down. Because of my peer link goes down and because of my peer keep alive packet is alive, right? My S1 is sending my keep alive packet to S2, and once the S2 will, what S2 will do, it will start the keep alive hold timer for 3 seconds. After that, it will start the timeout, and in that timeout period, because my peer keep alive is up and it's sending the packet, S2 will see that, oh, this can be a case of a dual active scenario or a split brain scenario. It will disable this link. So my secondary member port is down. To avoid the split brain scenario and dual active scenario, my S1 peer link and uplink is down because of M1 module down, but my F1 card is still active and the server is sending a traffic, but it is not having any uplink part to send traffic. So in that case, you will see a traffic drop. So in order to protect this, we have to configure a object tracking. So in that case, we will track the M1 card line protocol and a port channel line protocol. Once it goes down, what it will do, it will shut down the M1 sorry, F1 access port also here. So let me use different link color. So what it will do, it will shut down this cable also. So in that case, I have only one path available and my traffic will go from here to here. Okay. Now, if you want to see the command, what is the command available? Track 1 interface port channel, because this is a port channel 11. So what I have done, I am tracking via track 1 line protocol, track 2 interface ETH 1 by 1 line protocol, track 3 interface ETH 1 by 2 line protocol. So it is 1 by 1 and 1 by 2, right? And this is my port channel 11. Now I will track 10 list boolean or any of these cases is, if object 10 goes down on a primary VPC peer switch, system will switch over to another VPC peer and disable all its local port. So VPC domain 1 track 10. So this command we will write under a VPC domain. So once we do that, if M1 module goes down, what it will do, it will, S1 will shut down its F1 port access VPC member port, due to which my all traffic will switch to S2 and from S2 it will go up. Okay. Now, what is the VPC member port configuration? So VPC member port configuration is configured like that. VPC ID, right? So we have to create a port channel 10. Under that, we have to write VPC 10. Okay, and these port channel, these port channel member may contain up to 1 or 8 port if we are using M1 card, or 16 port if you are using F1 F2 card, right? And this port channel is a layer 2 trunk port or access port, and when it is used as a trunk port, we can allow a multiple VLAN on it, and when it is used as an access port, then we will allow only single port, single VLAN, right? So this is your best practices design. So if I am using a member port, this will be also M1 module. This will be also from M1 module. This will be also from F1 module. This will be also from F1 module. This will be also from F2 module. This will be also from F2 module. It should not like that. I am using a member port of M1 module here, and I am using a member port of F1 module. It will not support. So mismatch will not be supported. Likewise, we have seen in the VPC peer link, the both modules should be same. So for member port also, the both module should be same. So thank you for watching VPC configuration and best practices. Thank you very much. Take care. Bye bye.